हेलो स्टूडेंट, आज हम एडवांस इंजीनियरिंग मैथमेटिक्स के यूनिट नंबर 4 में लेक्चर नंबर 27 डिस्कस करेंगे, जिसका टॉपिक है स्पीयर्समैन रैंक कोरिलेशन। ए प्लॉट ऑफ द डेटा में रिवील outlying points well away from the main body of the data, which could unduly influence the calculation of the correlation coefficient. Alternatively, the variables may be quantitative discrete such as a mole count or ordered categorical such as pain score. A non-parametric procedure due to Spearsman is to replace the observations by their ranks in the calculation of correlation coefficient. This results in a simple formula for Spearsman rank correlation RHO. RS equals to 1 minus 6 summation of d square upon n into n square minus 1, where d is the summation of all difference of both the ranks of x and y, square of n is the number of observation, where d is the difference of rank of two variables for a given individuals. Thus we have a table. Let an example, child number is given here 1 to 15 and rank height 1 to 15 and rank dead space this given, and d square. सो द रैंक हाइट एंड डेड स्पेस, हाइट एंड डेड स्पेस में जो डिफरेंस है वो डी से डिनोट किया गया है, और इसका डी स्क्वायर निकाला गया, उसका समीशन निकाला गया, टोटल 60.5 आ रहा है। फ्रॉम दिस वी गेट आर एस इक्वल्स टू 1 माइनस 6 इंटू 60.5 अपॉन 15 इंटू 225 माइनस 1 इक्वल्स टू 0.8920. In this case, the value is very close to that of the Pearson correlation coefficient for n greater than 10. The Spearsman rank correlation coefficient can be tested for significance using the t-test given earlier. Now, Spearsman rank correlation coefficient. A correlation can be easily be drawn as a scatter graph, but the most precise way to compare several pairs of data is to use a statistical test. This establishes whether the correlation is really significant or if it could have been the result of chance alone. Spearsman's rank correlation coefficient is a technique which can be used to summarize the strength and direction, negative or positive, of a relationship between two variables. The result will always be between 1 and minus 1. Method: calculating the coefficient. Create table from your data. Rank the two data sets. Ranking is achieved by giving the ranking 1 to the biggest number in a column, to 2 to the second biggest value, and so on. The smallest value in the column will get the lowest ranking. This should be done for both set of measurements. Tied score are given the mean average rank. For example, the 3 tied score of 1 or in the example below are ranked 5th in order of price but occupy 3 positions 5th, 6th and 7th in a ranking hierarchy of 10. The mean rank in this case is calculated by 5 plus 6 plus 7 divided by 3 equals to 6. Find the difference in the ranks D. This is the difference between the rank of two values on each row of the table. The rank of the second value, price, is subtracted from the rank of the first, distance from the museum. Square the difference d square to remove negative values, then sum them, summation of d square. Here the given convenience store and distance from camp 1 to up to 10 values there, and 50, 175, 270, 375, 420 and so on values given. Distance from camp, rank distance given 10, 9 this way, and price of 50 calorie bottle. तो सबसे पहले डिस्टेंस फ्रॉम कैंप के लिए रैंक दी गई है 10, 9 इस तरह से। सबसे हाईएस्ट वैल्यू को 1 रैंक है जो 980 है, देन 890 को सेकंड रैंक है, उससे जस्ट छोटी वैल्यू है, 790 की थर्ड है। इस तरह से रैंक दी गई है। और प्राइस 50 लीटर कैलोरी बोतल्स के लिए जो प्राइस हैं वो इस तरह से दे रखे हैं, 0.85 ये इन सबको अलग रैंक दी गई है। यहाँ पर 1.20 1.22 टाइम्स आ रहा है, इसलिए इसकी रैंक को एवरेज करके डिवाइड बाई 2 किया गया, 3.5 3.5 आ रहा है। इस तरह दोनों की रैंक का डिफरेंस निकाला गया है, गिवन हेयर, एंड डिस्क्वेयर किया गया है, जो आ रहा है इसका सम 285.5। इस तरह से हमें रैंक निकाल करके उनका डी स्क्वेयर निकालना, उनका स्क्वेयर निकालना है, सम करना है। Calculate the correlation RS using the formula below. The answer will always be between 1.0 a perfect positive correlation and minus 1.0 a perfect negative correlation. When written in mathematical notation, the Spearsman rank formula looks like this: RS equals to 1 minus 6 summation d square upon nq minus n. Now to put all these values into the formula, find the value of all the d squared values by adding up all the values in the difference column. In our example, this is 285.5, multiplying this by 6 gives 1713. Now for the bottom line of the equation, the value n is the number of sites at which you took measurements. This in our example is 10. Substituting these values into nq minus n, we get 1000 minus 10. We now have the formula RS equals to 1 minus 1713 upon 990, which gives a value for RS 1 minus 1.73 equals to minus 0.73. What does this RS value of minus 0.73 mean? The closer RS is to plus 1 or minus 1, the stronger the likely correlation. A perfect positive correlation is plus 1, perfect negative correlation is minus 1. The RS value of minus 0.73 suggests a fairly strong negative relationship. A further technique is now required to test the significance of the relationship. The RS value of minus 0.73 must be looked up on the Spearsman ranked significant table below as follows. Work out the degree of freedom you need to use. This is the number of pairs in your simple minus 2 and minus 2. In this example, 8 into 10 minus 2. Now plot your result on the table. If it is below the line marked 5%, then it is possible your result was the product of chance and you must reject the hypothesis. If it is above the 0.1% significance level, then we can be 99.9% confident the correlation has not occurred by chance. If it is above 1% but below 0.1%, you can say you are 99% confident. If it is above 5% but below 1%, you can say you are 95% confident. Statistically, there is a 5% likelihood the result occurred by chance. In this example, the value 0.73 gives a significant level of slightly less than 5%. That means that the probability of the relationship you have found being a chance event is about 5 in a 100. You are 95% certain your hypothesis is correct. The reliability of your sample can be stated in terms of how many researchers completing the same study as you would obtain the same result 95 out of 100. The fact two variables correlated cannot prove anything. Only further research can actually prove that one thing affects the other. Data reliability is related to size of the sample. The more data you collect, the more reliable your result. Spearsman rank correlation coefficient. If the data are in the ordinal scale, then Spearsman rank correlation coefficient is used. It is denoted by Greek letter rho. Spearsman rank correlation can be calculated for the subjectivity data also. Like competition scores, the data can be ranked from low to high and high to low by assigning ranks. Spearsman rank correlation coefficient given by the formula rho equals to 1 minus 6 summation of di square upon n into n square minus 1, where di equals to r1i minus r2i. r1i equals to rank of I in the first set of data, r2i equals to rank of I in the second set of data, and n equals to number of pairs of observation. Interpretation. Spearsman rank correlation coefficient is a statistical measure of the strength of a monotonic increasing or decreasing relationship between paired data. It, its interpretation is similar to that of Pearson. That is, the closer to the plus minus 1 means the stronger the monotonic relationship. Repeated rank. When two or more items have equal value, a tie, it is difficult to give the rank to them. In such cases, the items are given the average of the rank they would have received. For example, if two individuals are placed in the 8th place, they are given the rank 8 plus 9 upon 2 equals to 8.5. Each which is common rank to be assigned, and the next will be 10. If with 3 ranks equal at the 8th place, they are given rank 8 plus 9 plus 10 upon 3 equals to 9, which is the common rank to be assigned to each, and the next rank will be 11. In this case, a different formula is used when there is a more than one item having the same value. And formula is rho equals to 1 minus 6 summation di square plus 1 upon 12 m1q minus m1 plus 1 upon 12 m2q minus m2 and so on upon n into n square minus 1, where mi is the number of repetition of ith rank. This phase lecture is completed. Thanks all of you.